Hello students, I am Dr. Sanjeev Ponia. This is your first lecture of 5th semester, so I welcome you all. In today's lecture, we will discuss about the examination stream of 5th semester. Then we will discuss about the subject that I will teach you. After discussing the subject, we will discuss about the prerequisite, then the objective of the subject, that what's the need to study the subject. After the objective, we will discuss the syllabus of the subject in detail, and in the last we will discuss about text and reference books. So let's start from the examination stream. In 5th semester, there are three core theory subjects, that is BCA 301 operating system OS, BCA 303 computer graphics CG, and BCA 305 e-commerce. These three are basic subjects. Those have to be read, but there is an elective that can be select from these five subjects. That is software testing, microprocessor, advanced computer network, web-based programming, and business economics. So you can choose any of one from these subjects, these electives. Generally, students select software testing or web-based programming It's depend on the strength of the student, that which subject is going to be select. So these are 4 theory papers, 3 the basic papers and 1 for the elective. So 3 plus 1 are 4 theory papers. After this, in practicals, there is only one basic practical concerned with the theory subject, that is practical based on computer graphics, that is lab of computer graphics. So this is a main subject where the lab is associated with the theory subject. And then a major project, we discussed in the last semester also, that minor project and major project. Your project start from 5th semester and it will complete in the 6th semester. In 5th semester, this is called minor project, whereas in the 6th semester, it will be major project. This summer project or summer training, BCA 355, you can see a star over here. It means that this is a NUES subject. NUES subject means There is no university exam. There is no exam from the university side of this subject. All the marks, this is 100 marks, all the marks are internal marks. So this is a NUES subject. I hope you studied these subjects in first year as well as in second year also. The credits of three subjects, the main three subjects are for computer graphics 4 and e-commerce 4. So the total credits of basic subject, or these are also called main subject, and this is a elective, so the credit of the elective is also 4 because we have to select any one among these. So this is 12 plus 4, that is 16. So 16 is the credit of the theory subject. Now about the CG lab, the CG lab has 4 credits, summer training has 2 credits, and project, minor project have 4 credits. So this is 4 plus 2 plus 4, that is 8. Means that is 4 plus 4 plus 2, 10. So total credits are 26. So in the 5th semester, total number of credits are 26. Total number of marks are 700, in which 280 marks are internal and 420 marks are external. So, students, I will teach you computer graphics in this subject. I told you in examination scheme that this is the only theoretical subject in which the practicals are associated with the theory. And one more thing you can see here, that total number of loads, that is practicals, is 8 hours over here. Instead of 4 hours, generally it is 4 hours in all the subjects, but in computer graphics over here, this is of 8 lectures, and the credits are also 4. In another semesters, you have seen that the credits of the practical subjects are generally 3, but here the credits of computer graphics is 4 plus 4, that is 8. So you should pay more attention on computer graphics. So I will teach you computer graphics in this semester, and the paper code for CG, this is also called CG in short. So the paper code for CG is BCA 303, whereas paper ID of computer graphics is 20303. Now there is one more good thing about computer graphics, that there is no prerequisite about this subject. It means it's not necessary that you should know any subject if you want to go ahead in the computer graphics. Means you can start computer graphics from the start. Anyone can study the computer graphics because there is no prerequisite for this subject. This is really very good. Otherwise, what happens that when you have to study a subject, then that subject is based on the subjects of earlier semesters. Generally, if you will see, then maths 3, maths 4 are based on maths 1 and maths 2. The objective of computer graphics is that we will try to understand the working of graphics hardware as well as software. We will try to understand the working of different elements of the computer. Second objective is to create interactive graphics, and we will perform these applications or these programs in C++. In C++, you studied this C++ in third semester as well as in fourth semester also. Third, we will discuss about the geometrical transformations. Means we will discuss about the transformations, means what the operations we can perform on object. Then in the last, we will try to discuss that how we can generate the animations in graphics. How we can generate animations using the computer graphics. So these are our objective, that how the processing is done to implement all the applications, how the different operations are being performed, and the interconnections of circuit. Then in last we will discuss about the generation of animations, as computer graphics is used everywhere in the life at each and every step. So this is really a practical subject. We will try to implement this subject using the basic knowledge. Now these were the objective of the computer graphics. Now we will discuss about the syllabus of computer graphics in detail. As per university syllabus, there are 4 units in each and every subject. So there are 4 units in computer graphics also. First unit is the introduction of computer graphics, then different graphics hardwares, and in third one, this is the clipping. When we will discuss about the introduction to computer graphics, then we will see that what is graphics and what is computer graphics. First, we will try to understand that what is graphics and what is computer graphics. Then we will discuss about the types of graphics, means classifications of the graphics. Then we will discuss the applications of applications of graphics and different hardwares, those are interactive. So from the first part of first unit, there is a question in the exam, and the question is generally like this: that what do you mean by computer graphics, and write down the applications of computer graphics. These questions come always in the university exam. Maybe the questions can be in another form, means what do you understand by computer graphics, like this. In second part of first unit, we will discuss about the graphic hardware, that how the display is going to be displayed on different units, and what's the operation, what are the different techniques by using the display can be better. So we will study about the display techniques, that is raster scan and random scan. These two are very important. There is always a question from this, that what do you mean by raster scan, or what do you mean by random scan, or there is a question that write down the difference between raster scan and random scan. Then after this, input device for operator interconnections and image scanners, as well as anti-aliasing. Generally, they ask anti-aliasing for the 2 marks, that explain about anti-aliasing. Generally, they asked about anti-aliasing. This is also important. And clipping is a technique by which we have to clip an object. So there we have to study three techniques: Cohen Sutherland algorithm, Cyrus Beck algorithms, and midpoint subdivision algorithm. In unit second, this is a unit that is concerned with the transformations of 2D as well as 3D object. So transformations is a technique by which we can change the location or the shape of an object. So we will study the 2D and 3D transformations. We will see that how we can represent an object in matrix form, and what is homogeneous coordinates. What are homogeneous coordinates? There is one question in exam from this. There is one question in exam from 2D transformations, and these are really very simple when you will study these. Next is window to viewport transformation. Window to viewport transformations means if we want to see an object from one display size to another display size, means when the display size is going to be changed, then how the object is look like. There is also a numerical question based on this. Always in the final exam, there is a numerical question from window to viewport transformations. Then we will discuss about the efficiency and all the different techniques that we studied in 2D transformation, same techniques in 3D transformations also. So two questions are really very important from this. First one, transformations on 2D object, and second one, window to viewport transformations. So two questions among this, and two questions, one question from this one and one question from this one. So let's try to see about the third unit. Unit 3 is concerned with the polygons, curves and surfaces. Means how we can perform different operations on curves. Suppose this is a curve. So how we can perform the different operations by using different techniques and methods. We will see here the polygon meshes, parametric cubic curve, and in solid modeling we will discuss about representation of solid modeling, then Boolean set operations, that how we can perform Boolean operations on the models, on the different models. After that, we will discuss about the instancing, swap representation, boundary representations, and constructive solid geometry. In last, we will discuss about the comparison of representations, user interface for solid modeling. From this unit, two theoretical questions comes. First question comes from this one, and second question comes from this is second question come from sweep representation or boundary representation. Fourth unit is concerned with the projection. This unit is also very important. In this, there are two questions based on projections, and these two questions are theoretical. Projections in three-dimensional 3D projections. So first we will discuss that what is three-dimensional projections. Then we will discuss different type of three-dimensional projections like parallel projection, orthographic projection, oblique projection, and perspective projection. After this, we will discuss about the clipping. We will discuss about the clipping. This is three-dimensional Cohen-Sutherland clipping algo. If you will go on the first unit, then you will see that in first unit also there is Cohen algorithm for clipping. Cohen algorithm for clipping in the first unit also. But in the fourth unit is for three-dimensional. This is for three-dimensional. Then we will discuss about the hidden surface removal method, that is depth buffer or Z buffer method, and second one is depth sorting method or Painter's algorithm. Among these two hidden surface removal method one question is asked always. Either that is based on depth buffer or depth is based on depth sorting methods. That is Painter's algorithm. Sometimes they asked in explanation in theory only that what is the difference between Z buffer and Painter's algorithm. The book that we will refer over here is huge. This is Computer Graphics Principles and Practices by Pearson. And this is the reference books. Baker is the reference books that we will follow. This is also the Pearson education. So we will use these two books especially. These are the two books, those are given in your syllabus textbooks, and these are the three books, those are given in reference book in your syllabus. But this Baker and these Hurts are very important books, so we will follow these books most of the time. So in today's class, we discuss about the examination scheme. We discuss about the objective, that's what's the need to study the computer graphics. Then we discuss the syllabus of computer graphics in detail and textbook as well as reference books that we will follow in computer graphics lectures. In next lecture, we will start first unit, that is Introduction to Computer Graphics. Thank you. Thanks a lot.